Okay, so this is going to relate to homework 6.7. We're going to be multiplying binomial, so a group of two terms times another group of two terms. And then you've probably seen this before or have used it. It's basically a FOIL method. And if this is new to you, when people say FOIL, it's just a method of or an order to distribute. So it stands for first, outer, inner, last. So multiplying, you can multiply whatever way you want to. It's just that this ends up actually making a word, right? We could multiply it backwards. We could do last, inner, outer, and then first. But then we would have this, and that's not a word, right? So we tend to say we're going to FOIL it out. So when we have um, my brain stopped. When we have a group of two or a binomial, we're going to have something like x plus 9 times x plus 4. This is set up for us to do this method, and then I'm going to show you another method of just breaking it up and distributing it one at a time. Either way works. I tend to just do this. So that's what you'll see me do for the most of this part. So when they say FOIL, they're saying we're going to take this first term times this first term times this first term. So this. So x times x gives us x squared. And then outer, well, if you kind of think of these as innies, then these are outies. These two right here. So they're kind of on the out level. So outer would be this times this. So x times 4, usually you write it with the number first. So we're going to have 4x. And then our inners, or our innies, this will be right here. So these are kind of, if these are on the outside, these are on the inside. So then we have 9 times x. And then last. So if these were first, if these were first, these are last. 9 times 4 is 36. Now this is great, but this as an answer can be simplified. So if you do it this method or something close to that, then these two middle terms should, for the most part, be like terms, and you should be able to add them. So 4 plus 9 is 13. And again, you don't change the x's, the exponents on these when you add. So in order to add, they have to be the same, and they're going to stay the same. So this will be 13x. Yeah. So that's one example. And then another way, if sometimes people kind of get lost in the sea of lines, so there's also a distribution method, and you can do this if this works better for you. When I have big groups of stuff, like if I'm doing a group of 3 terms times another group of 3 terms, so there's more stuff in here, sometimes I tend to do this method just so I don't forget something. We're going to take this same thing and we're going to break it up. So we're going to take this first term, x, and we're going to multiply it into here. So we have x times x, so we do that, and x times that 4, they have 4x. So we're done with this. We've already done that. Phew. So that's done. Now we're going to take this 9 and multiply it into that group as well. So again, distribute that in, multiply, get 9x plus 36. Again, you want your answer to be as simplified as possible. So usually that's what happens. We can add those together. So you get x squared plus 13x plus that 36. These are not like terms. These are not like terms. Can't add them. So this is why we stop here. Okay. So either way, whatever works for you. I tend to just kind of do that. So hopefully that'll be okay from this point on. So when we have plus plus, not too much to worry about sign-wise, but even though this is plus plus, it doesn't always say whatever this sign is and this sign is will follow that pattern. That's not technically true. So if we have the same signs, we see that this back number here is positive, right? Because a positive times a positive is a positive. But if we have the same signs, but they both happen to be negative, let's see what happens with that. Okay. So when we multiply these two, this is where you just got to be careful. We know x times x equals x squared. X times a minus 6 will be a minus 6x. Minus 5 times an x will be a minus 5x. And then a negative 5 times a negative 6 becomes a positive. All right. And again, we see that our two middle terms are the same, or they're alike, I should say. And this is another area of where trouble happens. So just, double check yourself in a calculator if you need to, but just remember that if you have the same signs and you're adding, or you're combining, I guess, and you have the same signs, add them, keep the same sign, okay? So if we had 6 and 5, when we combine these two together, they're both negative. So negative 6, so you're down 6, minus 5, so you lose 5 more. So we're going to combine those to make negative 11x. Okay. So be careful about signs when you're multiplying like that. And we see that here, again, same sign, back number is positive. Same sign, back number is positive. Okay. Both positive, middle term's positive. Both negative, middle term's negative. So sometimes just kind of keeping those like, I don't know, things to remember things, I guess, written down might help. Okay, but what if there are different signs? Good thing you're here, because that happens. So if we have, let's do x plus 11 times x minus 3. So here we have a positive times a negative. When we do x times x, we get x squared. And then x times this minus 3 will get us a minus 3x. So we're done with that x. Now here we have 11, positive 11 times x, positive 11x. And a positive 11 times a negative 3 will be a minus 33. Okay. And be careful here. These are different signs. So when you combine them, you're basically combining them using subtraction, since one's a plus, one's a minus. So think about what's the difference between 11 and 3. So 11 minus 3 gets us 8. And which number is bigger, right? Meaning which number here has the positive sign? 11. So the bigger number is what sign you're going to have right here. So since this is a positive 11x, positive 11 minus 3 gets us a positive 8x. Okay. Just also double check yourself, using a calculator. Because if we had this switched around, instead of x plus 11, let's say we had x minus 11 and x plus 3. Okay. We still get x times x, so that'll still be x squared. And now when we multiply this x to this 3, this is a positive, so now we have a positive 3x here. When we multiply this negative 11 with this x, we get a minus 11x. When we multiply negative 11 times 3, we still end up with a negative 33. So in this case, now when we combine this, we have positive 3 minus 11. So you're at above 0. Like if you had $3, but you spent 11, then you're down, you're in the negative land, right? So 3 minus 11 gets us negative 8x. So you see here where we are multiplying and we have different signs. One's a plus, one's a minus. Our back number will be negative, okay? The sign of the middle term depends on which sign the bigger number has. So between 11 and 3, right, 11 is bigger. It's got a positive sign. So here we have a positive sign. 11 is bigger in a sense, and it has a negative sign in this example. And so now our difference has a negative on it. So I'm saying all this because when we undo this, when we factor it out to get back to these, come full circle, knowing those things, keeping those in mind will make it easier. All right. So one thing to watch out for is if you have something that looks like this. Okay. So what is super, super, super tempting, right, is to do this. Do this all the time. Okay. But this is a big no. Never, ever, ever do that. Okay? Because if you have a group of terms, in this case, x plus 4, and we square it, that means that we're going to take whatever inside here and do that twice. Okay? It doesn't mean we distribute this exponent inside because it's a plus sign. So what this means is we're going to have x plus 4 times x plus 4. And we're back to foiling. So in textbooks and in your homework too, they go through like more like a formula or, a pattern, but just basically foil it out. That's what you got to do. So here, we're going to multiply these two together like this. X times x gets us x squared. X times 4 is 4x. 4 times x is another 4x. And 4 times 4 is 16. So you can kind of see, if you get into the instruction, there is a formula. You have double that, right? So 2 4s makes 8, right? And when we do 4 times 4, we get 16. So you just want to be careful that you don't try this. Don't try this at home because it's not going to work and it will be wrong. So don't do that. Same thing if we have a negative sign in there. Okay. So again, this means we're going to take this group and multiply it by itself, okay? Exactly how it is. We don't change any signs. So again, we have x times x gets us x squared. X times minus 1 is a minus 1x. Minus 1 times x is another minus 1x. And for some reason, this always, right in this back one, when we have this example, this back number tends to trip people up, but still the same pattern, right? -1 times -1 will be just a positive. Negative times negative is a positive. 1 times 1 is 1. These are not opposites. These are like terms, but these are like terms and they have the same sign. Sometimes we look at this and think it cancels out. No. Same sign, add it, keep the same sign. Same sign, add it, keep the same sign. That'll be your answer. And this is what they call difference, well, the result, I guess. Hold on a second. Let's do it first. If we have something like this, so now you see that we have the same stuff, but we have different signs. So the result has a name. X times x gets us x squared. X times this positive 8 gets us a positive 8x. Negative 8 times this x gets us a negative 8x. And 8 times 8 is 64. Negative times positive is a negative. And here, well, once you have the same stuff in the middle, and one's a positive and one's a negative, this is when they cancel out, right? 8 minus 8 is 0. 0 times x is still 0. So don't write 0x. It's just gone. So this is cancels. So we have 8x squared minus 64. So when we are factoring, when we get later, when we go from here back to this, you're going to see what they call a difference of two squares. So again, difference means subtraction, because when you take the difference, that's another term for subtraction, and the result of two squares. So x squared is x times x. 64 is also a perfect square because it was 8 times 8. So that's why they call this the difference between two squares. And we also have more stuff in there sometimes. So sometimes we might have something like this. Okay. So again, the process doesn't change. We just now have a 2 in front of this first term. So when we multiply this together, we're going to have, since no number in front, we can consider that a 1. So it'll still be 2 times 1. And x times x is x squared. And we multiply this, 2x times a minus 5 will be a minus 10x. Here, 3 times x. And now 3 times a minus 5. So again, the only like terms are right here in the middle. They're different signs. One's a plus, one's a minus. So again, we're going to subtract, take the difference, keep the sign of the higher number. So a negative 10 and a 3, the difference of that is 7. And then since our bigger number is negative, our sign will still be negative. Okay. So again, later, I'm going to show you a method of if this is your results, when you factor it, how to get back to here. Okay, and I think there's maybe one more example. Do a few more. So what happens when they start bringing in other letters, right? Process is still the same, just got an extra variable there. So here we have x times x, so that'll be x squared. X times this, nothing to combine. One has an x, one has a y. Do that. And then we multiply this. So we see this, and sometimes we just tend to write it, first come, first serve. So that's fine. And so if you write it like this 3y times x, it's okay to write this as 3yx. Here, we're going to have 3y times minus 2y. So 3 times minus 2 is 6. Y times y is y squared. And I said it's okay to write this as yx because when you multiply, you can multiply either way, get the same result, right? So a yx is the same as an xy. So these two are like terms. So again, one's a plus, one's a minus. So 3 minus 2 is 1. And so since our bigger number is positive, that'll be positive. Now, in your answer, how should you write it? Generally speaking, it's in alphabetical order. So X comes before Y in the alphabet, so you'd see that. And not sure how picky they are, but you can, in my world, you can leave the 1 there. That doesn't bother me. In computer world, they might want you to drop it, but either way. All right, let's do one more. Oh, wait. Throw some Y's on there. So again, we see that we have same stuff, different signs. So when we multiply these two out, this is the only time you get something with just 2 terms at the end, okay? So 4 times 4 is 16. X times x is x squared. 4 times 9 is 36. X and y together. 9 times 4 is 36. Positive, positive. Again, x and y together. And then 9y times minus 9y, so 9 times 9 is 81. Positive times a negative is negative. Y times y is y squared. So looks a little bit bigger, but actually it's not too bad because again, these 2 things in the middle are like terms. And there you have the same number, right? One's positive, one's negative. So this cancels. And so we're left with 16x squared minus 81y squared. So here again is a difference of 2 squares. 16 we get from 4 times 4, so that's a perfect square. X times x, so x squared is literally in the name. And 9 times 9, 81 with a y squared. So again, this is a perfect difference of 2 squares. So to recap, when you have the same sign, when you multiply it out, your back number will be positive, and your middle term will be whatever that sign is, okay? Just like here, same sign, and negative times a negative is positive. We combine those 2 middle terms, and we keep the same sign. We have different signs. Our back number is going to be negative, and our sign in the middle will depend on what sign the bigger number has. Okay? So if the bigger number has a positive, take the difference, leave a plus. Bigger number is negative, take the difference, make it negative. And if you have stuff that looks like this, write it out and FOIL it out, okay? This is never ever, better not see that, because that's gross. And if you have the same stuff, different signs, this is the only time you'll have your result that has only 2 terms. Okay? So 2 terms means you have the same stuff, one's plus, one's minus. Okay. I think that's hopefully good at this point. Good job. I'm going to try to stop recording right now.